Hello students. So today we are talking about uncertainties and error. I'm taking this classes separately because it's a big thing to tell about, and errors are something that you have to deal with till your professional life. Okay. Now starting from that error, this is the second chapter, that is units and measurement, so it comes under the measurement. So you know that how much accurate you are in measurement, still there will be some error. Now why error is happening? It happens because of many things. Okay, uh, error comes from many individual things. Now, so there is something, two terms are important in that case. One is called accuracy. Accuracy means how much uh, close your recorded measurement is with the actual measurement of that thing. Let's say you are measuring a needle in a ruler. So there is some needle, okay, and you are measuring the needle in the ruler. So see how much close you are. Still there will be some problem, because when you are measuring a needle in some ruler, let's say your zero start from here, but here you will see that it can be that it is not it is between two lines of the measurement, but there are no lines. The end, like this end, I'm talking about this end. Let's say this end is let's say in the middle of two measuring lines, but you cannot say the actual how, what will be the what you say, the data here, right? Because it is neither this and neither that. Let me say that let's say this is a meter, like a centimeter scale. In a centimeter scale, you know that there are 10 millimeters. Okay, 1 2 3 4 5 6 7 8 9 10. So and that will be your 1 centimeter, right? So individual, these small things are 1 millimeter. So the smallest thing that you can measure in a ruler is 1 millimeter. Let's say for the this last point of that needle, it is in the middle of 2 millimeter lines, so you cannot take the accurate data, right? So that's why we have errors. Okay, so there are two things which I was talking about. One is called your accuracy, okay, and another word is called your precision. Now what is precision? See, precision means how much precise you are in your measurement. That means how much small how small you can measure. Like in a ruler scale, you can measure up to 1 millimeter or 0.1 centimeter. So that means the resolution or the precision is 0.1 in that case. Okay, so these two things are important in case of error calculation. Now talking about the error, like how errors are generating, from where they are coming. So basically there are two types of errors. In your book also it is I think explained. There are basically two. One is called systematic error. Okay, so the first one is called systematic error, and the second one is called random error. Now talking about random error, I'll say that this error we have no control over it. Okay, so this random error can be due because of many things. Let's say you are measuring the time period of some pendulum. Okay, so in that case, what will create the random error? The random error will be created by any vibration on the suspension system, also like air. If there is a breeze of air and the air is flowing, that also can interrupt your time period. Okay, so this kind of error we have no control over it. So talking about random error, we better not to deal with this. Okay, but obviously you have to understand that there will be some error because of randomness of the nature of the system. Now systematic errors means there are error which is coming from the system itself. Like what are the components of it? Like you can say that instrumental error can happen in that case because of instrument. What is instrumental error? Instrumental error arises from the imperfection of the instrument, okay, or the calibration, due to the lack of calibration of it, like you have not tuned it correctly. So in that case it can happen, okay. So this is called your instrumental error. So how to solve these things? You have to check whether your instrument is working in a complete balanced condition or not. You have to check whether it is in faithful condition, like temperature and whatever will be the faithful condition for that instrument. You have to check whether it is calibrated or not, like the offset is at 0 or not, okay. So these things you have to check. Second thing can happen, or the second thing also can be there, which can generate this systematic error, that is your technical error. Technical error means let's say you have the procedure, but there is some problem in the procedure itself, okay. So that can also happen, and that can cause your the actual data to fluctuate, okay. Your data can be fluctuating with from the actual measurmental data. Also one more thing can happen, that happens generally for the maximum time, that is your personal error. So personal error basically occurs by observer, like who is taking the data. So talking about this one, we have to be very precise while taking the data. How to be precise while taking the data? Let's say you are measuring galvanometer, okay. You know, in a galvanometer one this kind of tip is there, like pointer is there, and there are some mark, right? And you have to measure the deflection, what is the deflection, how much it is rotated, okay. You have to see the deflection. Now let's say you are not looking from perpendicular view. In case you are looking from this angle, so if you are looking from this angle, your eye will see some different data. So always you have to see from up, so that you get the best data, and that is the procedure. You have to see from up. So if you don't see from your perpendicular aspect of view, then it can cause some error, and this is called your perpendicular error. So it is called your perpendicular error. So personal error means perpendicular error is one of the part of it, okay. Errors. Now these things are the basically error that can come when you take observation, okay. Oh, one more thing I have missed, that is your parallax error, whatever you have read till now, parallax. So some parallax error can also be your personal error, okay. Now coming to one vital thing, that is called your least count. What is your least count? The smallest thing that you can measure, that is your least count, okay. So the least count means basically the smallest value that you can measure. So least count is basically a limit of any instrument. Let's say you are using a centimeter scale, so the smallest value that you can measure is 1 millimeter, so that is your least count. Let's say you are using screw gauge, okay. So for a screw gauge, you will see that for screw gauge the least count, like it is called something else, okay, in screw gauge, but basically the concept is same. Okay, in that screw gauge it is this much. In vernier calipers, one more thing you will also learn how to measure, like smallest thing from vernier calipers is this much, and for our ruler scale it is that much. So that is for our scale ruler, and that is for our screw gauge, okay, screw gauge, and that is for our vernier calipers, okay, calipers. So basically these things are called least count, which you can measure at least, like the smallest value that you can measure, that is called your least count. Okay, so what next we are going to read about? We are now going to come to our main thing. Okay, so see, whatever I have told you, that you can read from book for more reference and to understand deeply. Now coming to the main part, how to deal with errors. Sorry, so dealing with errors. Now see, I'm giving you let's say one example, that is, let's say I am taking some data, okay, and my datas are coming like this. A1 is my first data. I am using the same notation that is used in your book, and mostly the same what you say methodology what is used in your book, so that you can see from the book and you don't be confused. So let's say A1 is my first data I have taken. So my experiment is basically same. Let's say I am taking the time period of that pendulum. Okay, so first time I see the time period has come A1. Second time again I measure A2. Third time I measure A3. Fourth time A4. Like that I have taken many times. Let's say I have taken n times. So these are all of my what you say result basically. So if you say Kisa, then which one I will take? So many results we have. So in that case you have to take first the average. Okay, so a mean. How to do mean? You have to add all and you have to divide by the number of that observation. Okay, so I am adding everything, and how many observations I have taken? N times, so divided by n. So basically my a mean is my sigma, that is summation, that means the addition, okay, by n. So one thing you can see that this symbol is called sigma, okay, that means your what you say addition. So a here starting from 1 and going to n, so n start from 1 to n. So you can use here n, I, whatever you can use here, I even. So let's say, because in mathematics you are going to use like that, so I am using the same notation. So I starts from 1 to n. So this is my a mean. Now so you can see that if I plot all the data, okay, so I will get that they are creating a shape like this. This is called Gaussian distribution. You don't need to know this now, but just for reference I am telling you that. So if you plot all your data, okay, all the values, so you can see that the data will like this is, let's say, the number of the value of data, and this is the number of observation that you have taken. So basically you can see that a mean will be somewhere here, okay, somewhere a mean. So this data will be your, let's say, a mean. So you can see that all datas are having a shift, right? So all the datas are having a shift. So if you calculate all the shift, then those shift will be called as absolute uncertainty. That means your, let's say the first data a1 is having one shift, right? So you can do mean minus a1. Now one thing you can see that this a1 can be even greater than a mean or even smaller than a mean, so the term can come negative as well as positive. So my uncertainty, I say absolute. Why? Because I want the error to be always positive. So uncertainty of one data is always positive because we take the mod of it. So a1 is there was this one, delta a2 will be your a mean minus a2. Okay, now these things are called absolute error or uncertainty. Now there are so many absolute uncertainties, so how many will be there? N terms, right? But which one to take? So I have to like consider for like whenever I will write the exact data, so I cannot write this all, so I will take one. So which one is we have to take? So we take again the mean of absolute uncertainty. Okay, so the mean of absolute uncertainty will be my delta a mean is my all of the uncertainties, absolute uncertainties. Acha, one more thing is there, this delta means error. Okay, this delta sign means error, or you can say a small portion, in that case here we are like using it as mere error. So delta a2 like that, dot 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 dot, so delta n an, how many observation we have taken? N. So ultimately I will get this term, and this term I will use in my final expression. So my final expression will be how? So my final expression will be a mean plus minus delta a mean. So when I will write the total expression of that measurement, I have to write this, wherever this thing will be called absolute error. So you don't have to say average absolute error or mean absolute error. So basically people like by like if you tell someone absolute error, they will automatically understand that you are talking about the mean of the absolute error. Okay, acha. Now let us talk about more two things. Okay, something is there which is called relative mirror. Now see, relative, the word relative means you are comparing with someone. So what is your relative error? Relative error means your delta a mean by your a mean. Now what is that? A mean means whatever the actual data you have got. Okay, that means in that case my reading a plus minus delta a, I'm not using mean because you must understand from now, if I don't write m, it means it mean. Okay, so in that case delta will come here and a will go there, and this term will called relative error. That means with respect to my original data, how much error I am getting. Okay, that means per unit my original data, how much error I am getting. Something also is there which is called percentage of error. So percentage of error is the like what you say, basically that same thing, that you have to multiply 100 with your relative error. So my percentage of error is basically denoted like this, and it is like I have taken the notation from your book only, NCERT, and this you can write your relative error, that is this much into 100. Whatever will come, that will be your percentage of error. Now So how to define some quantity? Let's say you have taken what you say data of measurement, successive measurements, okay, and every time you have got some data like 5.6, another data you got 5.7, again 5.6, again 5.8, 5.5, 5.4, like this. So how many data? 1 2 3 4 5 6 data I have taken. So what you have to do, you have to first find out the mean of the data. So first you find out the mean of the data by adding them all. Okay, so summation of all A divided by how many observation, in that case 6. So you first find out what is your A mean, right? Then what you have to do, you have to find out individual your absolute errors, that is your delta A1, that means for this one. So what you have to do, you have to subtract that data, okay, from your mean value, and something you will get, understand? Then what you have to do, you will get, so in that case, in this manner you will get all the uncertainties, absolute uncertainties. Then again you have to take the mean of all absolute uncertainties, okay. So once you've taken the mean, so you will find this thing is summation of all my uncertainties, sorry, delta uncertainties divided by how many. So in that case we have 6 data, so again 6, so whatever you'll get. And at finally what you have to write, you have to write this value and plus minus this value. So ultimately my data will be A plus minus my this delta A mean. So A mean plus minus delta A mean. So this I'm not calculating here, but I am just telling you how to do this thing. So this is how you have to calculate, okay. Now talking about some more interesting facts, okay. So we will see now ki if you have let's say A is we know that A equal to B plus C, and the value of B and C is given. Let's say B is given 5 plus minus 0.01. So this has been this somebody has got by calculation, okay, like whatever I have mentioned before, okay. So and your B, A and C is given, let's say 6 plus minus 0.2. You have to find what is A. Now in that case what you will do, now we know that B plus C, these values will add up, that is so very much clear. So my value of A will be, first one will be 11 plus minus, now here what I will use, that is a big question mark. So basically we don't know the operation regarding this answer absolute errors, okay, ki how, what will happen to they. So will they directly add it up, or will they will have to do, will like this value we have to deal something else, okay. So we don't know like how to deal this to absolute uncertainties so that we get a resultant value. So before we go into this one, let us do some general calculation. So let's say I have that thing only, but this time I'm doing it generally. My B is my B plus delta B, this is my observation, and my C is C plus delta C. So my total A will be obviously A plus delta A. If I put the value of B, so B is B plus delta B. If I put the value of C, C plus delta C. Now we will say if this B plus C is A, so basically in the position of B and C I can put A, right? So A is equal to, so wait, a plus delta a is equal to a plus delta b plus delta c. So you can see a gone, so I got a finally delta equal to delta b plus delta c. So you can see that in case of addition, my resultant uncertainties are addition of my individual uncertainties. So in that case we can directly write my value of a will be b plus c. So my actual value, that means a mean, will be 11, and then plus minus, so delta a. So in case of delta a, so I'm writing the general thing here. So in case of delta a, I have seen delta b plus delta c I can do. So what is my delta b? My delta b is 0.1. And what is my delta delta c? My delta c is 0.2, and my delta b is 0.1. So I can directly write my delta a will be 0.3. So in case of addition, they added up. In case of subtraction, what happened? Now, one very interesting fact. Okay, errors do not subtract. Errors cannot be subtracted. Okay. Subtracted. So basically this is very useful thing you have to remember. Okay, so errors cannot be subtracted, so they always added up. Okay, why? Because we don't want to take a chance. Even you can say, sir, sometime it can be key I have done something some error I have done, and then I have taken a smaller data, so ultimately both cancel out. So I will say no. In physics we don't take a chance, so we added up everything. We want everything to be accurate, so in that case we add all the errors. Okay, so in case of basically what you say subtraction, let's say this is a equal to b minus c. So in that case also your delta a will be your delta b plus delta c. Why? Because absolute uncertainties will add up in that case also, because you remember in absolute uncertainties I have taken the mod value. Have you seen? This is the mod value, right? So always I have taken the mod value, so they cannot be negative. Now, so in case of subtraction also they add up. Now the little bit complicated things that will come when we say about multiplication. Let's say we have V equal to IR, that means our Ohm's law. The current I have measured, let's say, is 5 amp plus minus 0.1 amp. So let's say I have measured with ammeter, and the division, the smallest division of my ammeter is this much. So obviously there can be some the least count is this much, so obviously there will be some error, so this is 0.1. And my R is, in that case, let's say 6 plus minus 0.2. So in the both case, how to do, now to find delta V I have to do something, but in this case absolute error will not add up. So let us find out a general form. So let's say your V equal to IR. So with my whole expression I will get V plus delta V equal to I plus delta I plus, sorry, why I'm giving plus, into R plus delta R. Now if you just multiply this all, so you'll get IR plus I delta R plus, your delta IR, plus, delta I R, plus, your 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 delta I R, plus plus delta I delta R, and this is my V delta V. Now you know that V equal to IR, so these two terms will cancel out. So ultimately you will get delta V equal to, but I will not cancel out these two things. Okay, I will do something else. So because see, in that case, in this case, you can see with like absolute uncertainty, it is very hard to do, like, because it's a big expression. Now if you look at this expression, we know that errors are very small, but you also know that if two fractions are multiplied with each other, they become smaller fraction. So in that, that's why this term is neglected. So this term will be negligible because it's a small term, because delta I is also very small because it's a fraction. See, it's a fraction. This part I'm talking about, this part, it's a fraction. This is also a fraction. So delta I and delta R both are fraction. Okay, so in that case, that term can be neglected. Now so what we get finally, we get finally V plus delta V equal to IR plus I delta R plus delta IR. That's it, and that part is neglected. Now I will divide the both side by V. So what I will get, I will get 1. So see, in this case I'll get 1 plus delta V by V equal to, again 1, because IR is equal to V, right? V equal to IR. So IR by V is 1 plus I by delta R by V and plus delta IR by V. Now in the next line I can cut this 1 and 1. So delta V by V is equal to, see, I by V is 1 by R, so it can be written like this, and delta I R by V, that is 1 by I, that is, so this thing we can get it from this relationship, V is equal to IR. So finally one thing you can see that in case of product, like in case of this thing product, okay, sorry, in case of this product, absolute uncertainties always we cannot like adds up. Instead of that, the relative uncertainties add up. So what you have to do to find the value of these things, so basically you have to first find out the relative uncertainties, then you have to add them, then you have to again convert into the absolute uncertainty. So how to do this, I am showing you, very easy. So this math I am going to do at the last. Let me take this slide. Okay, so see, first of all I have to find out delta I by I, that is my 0.1 by 5. So this is my relative uncertainty, and also I have to find delta R by R, so that will be my 0.2 by 6. So this 2 are there. So ultimately I know that the relative error of delta V by V is also the add up of the relative errors of delta R by R plus delta I by I. Now these values I know, so I can directly put them here. I am not going into like calculation, but just showing you so that it will be quick. So see, so in that case you got already delta V by V. So whatever you will get from here, if you multiply this whole thing with your value of V, So you will get automatically your absolute value of V. So you can see that the V value will be your I into R, that is 5 6 are 30. So the value of V is 30. So ultimately what you will get your delta V is equal to that 0.2 by 6 plus 0.1 by 5 into 30, because my V is IR, right? So the mean value of I and mean value of R I have to do. So ultimately what will be the final result? So final result will be my 30 plus minus, I am not simplifying this whole expression, so I am writing the whole expression here. So 0.2 by 6 plus 0.1 by 5 into 30. So this will be your result. So it's basically, it's not that hard, okay? Like what you have to do, you have to first find out the relative error, okay? After finding the relative error, you can add them, then you can find out the absolute resultant error, and you can use that in your final expression. So this expression is basically V plus minus delta V, okay? So your delta V is this whole thing, okay, and your V is 30. So these things are there. Also we have for division. So in case of division also you will see that there is nothing subtraction. So in case of division you can find out. I am leaving this part for you. If you cannot do, then I will solve it. Like let's say some pressure is equal to force by area, okay. Or we can say one more thing, like tension equal to, it will be little bit easier more, the tension equal to your force by length. So in that case, if my force is given, let's say 5 Newton plus minus 0.1 Newton, and my length is given like 6 plus minus 0.02. So in that both case also, my delta T by T will be my delta F by F plus my delta L by L. So basically in this case also, in division also, the relative error adds up, okay. So these two things you have to remember. Now more things are there, okay. So talking about more things, let me tell you ki if something is there where you have to do square or something, like your area is equal to length square. So length squares, but a length is given, okay. Let's say 0 plus minus 0.2. In this case what you will do? So in that case also we can find out the general one, okay. Let's say the final one will be delta A is equal to, so this will be L plus delta L whole square, right? I'm rubbing it, okay, so that I can show you the general thing. So if we split this, this will be L square plus 2 into L delta L plus delta L square. Now I told you already, delta is L is a fraction, so if you are doing squaring it will be much smaller, so you can ignore that thing, right? So my final expression will be this. I will divide everything by A, so I'll get 1 plus delta A by A equal to L square is A, so basically 1, this will be 2 into L delta L by A. I'm ignoring that. Now so 1 and 1 gone, so ultimately I got delta A by A is basically my 2 into delta L by, now see A is L square, so if I put here L square in place of A, so ultimately there will be 1L, right? So ultimately I will get 2L by L. So basically you are seeing where the formula was A equal to L square, so this indices is coming in front of it, like multiplication, okay. So the the relative error of A will be twice of the relative error of delta L. So if something is there, let's say the volume, so in case of volume V equal to L cube, so in that case your delta V by V will be 3 into delta L by L. So basically when the indices is there, so basically it comes down and multiplied with our relative error. Okay, now more things like if minus is there, minus inverse something is there, let's say A equal to 1 by x to the power minus 1 and x values are given 1 plus minus 0 2. So in that case, okay, so there is nothing called minus, so ultimately you can write this x to the power minus 1, but your relative index sorry, the relative error will be your delta x by x. Let's say it is not minus 1, instead it is minus 3, so it will be multiplied by 3 but not minus, because we don't take minus in case of error. So in case of minus 3, minus 4 also the same thing will happen, like the indices, only the magnitude of the indices will come in front of the relative error. And the last thing, that is your logarithmic function. Let's say y equal to log x. So you will learn what is log in class 11, I think. So in case of log x, let's say x values are given, let's say 0.2 plus minus 0.001. So in that case the delta y is basically your delta x by x. So in this case the absolute error of y will be the relative error of delta x by x. But how it is coming, I will just show you. But if you don't understand, come back after you have completed the logarithmic section, like logarithmic chapter, then again you see the video and then you will understand what I'm doing. So basically in this case you have to do differentiation, because like log function you cannot split, right? So basically if you do differentiate this thing, you will see in differentiation chapter also that differentiation of log x is so differentiation of log will be dx by x. So like d is here very small quantity, and in case of error calculation this term is same as this term. So that's why we can write this. In case of log, we know that log means it's 10 base, right? But sometime we use ln also. So if we use ln, so if you use ln, like L equal to ln x, in that case what will happen? So first you have to convert into log. So we can write this is e base. Okay, so in that case you can write log of x by 10 pi log of 10 by e. So basically this is a formula. You will not understand now, but this video will be saved here in the YouTube, so you can see when you have completed, because this will be very useful for your further entrance exams maybe, or any international exams. So after that what you have to do, see ln 10 means this will be ln 10, because instead of log e 10 log e I can write ln. So ln 10 into y will be my log log 10x. And in that case if we take the if we do this same thing here, like dy dx, this thing here, so this part ln 10 will come in front. So ultimately what we'll get, so we will get delta y equal to my 1 by ln 10 delta x by x. So this happen only in case of ln function. Okay, so this happen when y equal to ln x, and the general formula is this one, delta x by x for y equal to log x. So basically these two things are there, and what else we have seen? We have also seen that if we have addition like a equal to b plus c, then my absolute error adds up, so delta b plus delta c. If we have subtraction also, so in both case, so I'm writing here, if a is plus minus b plus b plus minus c, in both case absolute error adds up. Okay, so absolute error adds up in that case. In case of a equal to b into c, or a equal to b by c, in the both case my relative errors adds up. Achha. In case of like say square or any indices, I'm writing here n, in that case the absolute error will be multiplied by the indices itself. And lastly the log, which is very uncommon. I think it will not come, but if it comes sometime, so you'll be ready. So in that case absolute error will be the relative error of our data. Okay, so these are basically the notes, the summary of our whole topic. This is a vast topic, so I have given you some maths, one worksheet. I think 5 maths are there. Please try those math and read the book. If you don't read the book, because I startled here while taking online class, because like I am very uncomfortable in this way, so I have some speaking problem also in this way. So whatever you are doing, please try to read the book. If you don't understand anything, please interact, because many of you are not interacting with me. I don't know whether you are like following my videos or not, you are following the classes or not. So that will be a very big problem. So please do see those videos and stuffs. Okay, and try to use these formulas to find out uncertainties. Okay, so for today this much is the class, and I have given you one worksheet. Try to do that, and please see that read that note, because I have sent you one note. That note is a summary of the whole chapter, so instead of reading the book also, you can see the note for your what you say concept, the building, to build the basis of your concept. Okay, so basically this is it for today. So bye bye.